Matter has mass and it has volume, so it occupies space. There are more than 3 states of matter, but for this class you only need to know the 3 main types, which is solid, liquid, and gas. Solids have definite shape. Liquids and gases do not have definite shape. They will always take the shape of the container they are in. So if I put liquid in a cup, it will take the shape of a cup. If I put the liquid in a bathtub, it will take the shape of a bathtub. Gas will take the shape of whatever container it's in. If I fill a balloon up with helium, it takes the shape of the balloon. Solids and liquids have definite volume. So if I have a solid that is 1 meter cubed, I cannot put that same solid all into a 1 centimeter cube volume. If I have 1 liter liquid, I cannot put that in 1 cup. So solids and liquids have definite volume. Gases do not have definite volume because they're so spread out. If I had enough pressure, I could squeeze all the molecules into a small volume container. Solids are rigid. They are not really flexible. Liquid and gases are not rigid. Solids and liquids are not compressible. I cannot squeeze a solid to a smaller shape. I cannot squeeze a volume of liquid into a smaller volume. However, gases are compressible. I could take a large volume of gas, exert enough pressure, and I could make the volume much smaller by squeezing it tightly. For solids, atoms and molecules are tightly packed. Liquids, the atoms and molecules are a little looser, so they can slide back and forth. Gases, the atoms and molecules are free to roam. They're not held tightly. Solids in general, molecules and atoms vibrate in place. Liquids, the atoms and molecules vibrate and rotate, so they are able to slide back and forth, and so it flows. Gases can vibrate, rotate, and translate. Translate means it could go into X, Y, Z direction, so it's able to slide as well as flow. A solid can become a liquid can become a gas, and vice versa. When a solid becomes a liquid, it is called melting. It melts by absorbing or taking in energy. A liquid can become a gas by vaporizing, by taking in more energy. A gas can be turned back into liquid by expelling energy or releasing energy, and that is called condensing or condensation. A liquid can become a solid by, again, releasing energy, and that is called freezing. These are all phase changes. A solid can also become a gas directly, and that is called subliming or sublimation. Example of a solid becoming a gas is carbon dioxide. Dry ice. Dry ice, you do not see a liquid state. It goes from solid to gas. Opposite is gas to solid. That phase change is called depositing or deposition. Example of that is if you have an old refrigerator, if you open the freezer, air goes in quickly. You close the freezer, the temperature drops suddenly, so the air molecules become ice. So every once in a while, you have to defrost the freezer because it gets caked with ice. Physical property is one that is observed without changing composition or identity. So the molecules or atom it's made up of before and after remains the same. Chemical properties are observed due to a change in composition or identity. Example of physical is density. Density of water, pure water, no matter where we are, whether I have 1 liter, 2 liter, 1 cup, remains constant. It is 1.0 grams per milliliter. Color is another example, but color can also be chemical. Color is also another example of physical. A piece of metal is silver in color. Phase change is also a physical property. Phase change going from one state of matter, solid, liquid, gas, to another is a physical property. For example, if I have an ice cube is frozen. It is made up of H2O. I melt it. The melted ice cube becomes liquid. That liquid is made up of H2O. It is the same composition. It is made up of hydrogen and oxygen. Malleable is another property. Malleable means pounded into thin sheet. If I crumple aluminum foil and then I flatten it back out, it's still made up of aluminum. Ductile means pulled into thin wires, so I could take any piece of metal and pull it into thin wire, and that is the same property. Odor is smell. Temperature is another one that can be physical or chemical. If I add heat to ice, it melts, so that is a physical property here. Texture is the touch. Chemical oxidation, it reacts with the air and it gets darker. Example of that is if I cut a piece of apple and it turns brown because it reacts with the air. Tarnished is another property that is chemical. So if you have Thanksgiving or Christmas or any special event and you use real silverware, a lot of times you have to polish it because the top layer has tarnished or oxidized and you have to remove that dark layer. Flammable is another one. Combustion is to burst into flames. Gas production and precipitation is another word for solid being produced. These physical and chemical properties will cause a change when there is a reaction. A physical change is one in which after the before and after, there is no change in composition or identity and is reversible. So for example, if I read a piece of paper in half, the paper itself before and after are the same. It is made up of pulp. I could put the paper back to its original state by taping it together. The composition of the paper did not change. Phase change is another one. If I have copper metal and I melt it, it becomes liquid copper, but it is still made up of copper atom. Chemical change is in which there is a change in composition or identity. It is not reversible. So if I have a piece of wood and I burn it, the wood before and the wood after are not the same. Afterwards, we might have a wood, but we have flame, we have smoke, we have light, we have soot, which is not the same composition as the original piece of wood. Decomposition is another one that is a chemical change. If I have food or plants or trees, they decompose. The final product is not the same as before. Grass growing is also another chemical change. In order for the grass to grow, it must undergo photosynthesis. Pause the video and see if you can identify the following as a physical or chemical change, and then justify your answer why it is a physical or chemical change. Number 1, ice cube is left out. Later, a puddle of water is present, and then a little bit later, the puddle is gone. This is an example of a physical change. It is a physical change because it went through various phase changes, and phase change is a physical property. Example of this is a solid state. It went to a liquid state, and then it went to a gas state. In all three states, the composition of the material was the same. It was water. The ice cube was made of H2O, the puddle of water was made up of H2O, and the gas evaporated H2O gas. Tablet is crushed. This is also a physical change. The tablet itself is made up of whatever chemical it is. Now if I crush it, it is smaller. It is smaller tablets made up of the same material. Statue of Liberty is a chemical change. It is a chemical change because it reacted with the air and oxidized. And oxidation is a chemical process. The color of copper, you guys know, is around like orange brownish, but when it reacts with the air, the copper turns green, and so there was a chemical reaction. On number 4, copper wire is turned into a coil. This is a physical change. It is a physical change because the copper wire, all it did was change shape. The coil itself is made up of pure copper, so the composition is constant. Avocado is cut in half. This is also a chemical change here because the avocado, once it's cut, it's going to oxidize with the air. This is why when you cut an avocado and you don't finish it, it turns black or brown. Cookies are baked. This is also chemical change. I cannot take the baked cookies and reverse it back into cookie dough. Blow dry wet hair. This is a physical change. The hair, when it's wet, when it's dry, it is still the same hair. The water in the hair was evaporated or vaporized, so there is no change in composition. So a physical and chemical change, 2 things. A physical change has no change in composition or identity, and it is reversible. A chemical change, there's a change in composition or identity, and it is not reversible. Matter can also be categorized as pure substances or mixture. A pure substance contains one element or compound. It has definite chemical and physical properties, and it retains its own identity. Pure substances can be further broken down to element and compounds. Element is the simplest form of matter. It is one kind of atom. Every single element is on the periodic table. Compounds are 2 or more elements combined chemically. They must combine in definite proportion. So for example, carbon dioxide has 1 carbon to 2 oxygen. Water has 2 hydrogens to 1 oxygen. Example of that is water, C6H12O6, which is glucose. Matter can also be categorized as mixtures. A mixture is 2 or more pure substances combined. The physical and chemical properties vary because there is no chemical reaction, and they do not mix in definite proportion. So for example, if I have sand and water, I could have a lot of sand and very little water, or I could have very little sand and a lot of water. In both cases, this is still sand and water. Mixtures can be further broken down to homogeneous and heterogeneous mixtures. The easiest way to memorize this is learn the root word. Homo means same throughout. Hetero means different. So a homogeneous solution is uniform composition and appearance. A special name for homogeneous is solution. A solution has 2 parts. Solute, which is being dissolved. Solvent, which is doing the dissolving. The universal solvent is water. Examples of homogeneous mixture is brass, Kool-Aid, and salt water. So if I have brass, no matter what part I cut out, the composition is the same. It's uniform. If I take a teaspoon of Kool-Aid from the top, middle, and bottom, it is again the same, uniform composition. Same goes with salt water. Heterogeneous mixtures are non-uniform composition, so it's different throughout. There are 2 or more pure substances combined. It could be 2 elements or more. It could be 2 compounds or more, or it could be a mixture of elements and compounds. Example of that is Rocky Road ice cream. Each bite of Rocky Road ice cream you get is not the same. Sometimes I will get a marshmallow. Sometimes I will get nut. Sometimes I would just get the ice cream. Another example of that is chocolate chip cookies. Each bite of a cookie will not have a chocolate chip, not uniform throughout. Another example is the ocean. The ocean water. there are rock, garbage, there are fish at different locations. So if I take a sample at different points, it is not uniform. Identify the following as pure substances, element or compound, or mixture, homogeneous or heterogeneous. Justify your answer. Pure zinc. Zinc is an element on the periodic table, so this is a pure substance that is an element. Boba is a heterogeneous mixture. Boba is a heterogeneous mixture. It is heterogeneous because it could be made with tea, milk, and on the bottom there's boba. So each time you drink your boba, it is not the same throughout. The composition, even if you view it, it is not the same throughout. Blood is also a heterogeneous mixture. There's platelets, plasma, all these other particles floating around. And so since it is not uniform throughout, it is a heterogeneous mixture. Garden soil is also a heterogeneous mixture. If I take a sample of garden soil, no matter where I take it, it is not the same throughout. You might have fertilizer, you might have rocks in there, you might have a little grass in there, you might have bugs in there. Pure alcohol is made up of carbon, hydrogen, and oxygen. So this is a pure substance that is a compound. Bottle of green tea, if it is pure green tea, this is a homogeneous mixture. So a bottle of green tea, there are no leaves in there. My first sip, my middle sip, my last sip is the same. It is uniform throughout. If we are talking about green tea that we make with leaves and there's leaves on the bottom, yes, that could be a heterogeneous mixture. Mixtures can be separated by physical means. Here are a list of 6. There are more than 6 available. The easiest method of separation is hand sort. So if I have a salad, I could use my fingers, separate the lettuce into a pile, the onions in a pile, and tomatoes in a pile. The second process is filtration. To separate sand and water, what I do is I set up a filter. On the bottom, I have an empty beaker. I insert a filter paper, so there's a filter paper inside the funnel, and I pour my sand and water mixture. In the filter, you will have the sand, and then the water will be separated in the bottom. Another separation and mixture process is called evaporation. If I have salt water and I leave it out, the room temperature or heating it up will cause the water to evaporate, leaving the solid behind. Distillation is another process using different boiling points to purify. An example of this is if you have a mixture of different alcohols have different boiling points, and you could boil them off into different chambers using the distillation process. Number 5 is chromatography. Chromatography can separate different mixtures by their mass. For example, a black pen is composed of different colors. So using a chromatography paper, you mark the bottom of the chromatography paper, insert it in a beaker of water or alcohol, depending on what base the pen is made up of. Place the filter paper in. The ink will separate into its different colors. The dye with the lowest mass will travel faster, and the dye with the heavier mass will stay below. And the last one here is magnetism. So if we have sand and iron filing, we could remove the iron filing by using a magnet or running a magnet through it. Here is a summary of matter. Matter, you know, is composed of 2 properties. It must have mass and it must have volume, which occupies space. Matter can be further broken down into pure substance and mixtures. Mixtures can be separated by physical mean. A mixture can become a pure substance through physical mean. Example of that is salt water. I could evaporate the water through physical means, and you have salt and you have water, which are pure substances. Pure substances can be further broken down into elements and compounds. Elements are anything that's off the periodic table. It is one kind of atom. When two or more elements are combined chemically, that is a compound. This is why a compound can become an element using chemical means. So for example, water is a compound. It is H2O. We could break water down into hydrogen and oxygen by putting electricity to it. That is called electrolysis. Mixtures can be categorized as homogeneous and heterogeneous. A homogeneous is also known as a solution, and it has uniform composition. Heterogeneous mixtures are non-uniform composition, so it is different throughout. Understanding matter and its properties, both physical and chemical, as well as how they are categorized, help you understand the environment around us.